Limits at Infinity, Part 2. Horizontal asymptotes and end behavior of rational functions is where we're going to begin our discussion. Recall that if the degree of the denominator is greater than the degree of the numerator, then the horizontal asymptote is at y equals 0. If you look at this expression, you have 3x plus 2 on the top. That's of degree 1. And on the bottom, x squared minus 1, that's of degree 2. So this is what I call bottom heavy. The degree of the denominator is greater than the degree of the numerator. And in that case, what you get is a limit of 0. What about the degree of the numerator and the degree of the denominator being equal? Well, in that case, you just take the ratio of the coefficients of the leading terms. Let's look at an example. Both the numerator and the denominator are of degree 4. So all we need to do is look at the coefficients 40 and 10. The ratio of 40 over 10 is equal to 4. And so there's a horizontal asymptote at y equals 4. If the degree of the denominator is less than the degree of the numerator, then there is no horizontal asymptote. Let's look at this one. We have a quadratic in the numerator and a linear expression in the denominator. So this is what I call top heavy. When it's top heavy like this, there is no horizontal asymptote, and the function continues to grow either in a negative or positive manner. So in this case, we're going to have to ask ourselves not what is the horizontal asymptote, but is the limit infinity or negative infinity? Well, to analyze this, there's a few different ways you can do it. One way you can do it is look at the degree of the denominator. The degree of the denominator is 1. So we multiply the top and the bottom by 1 over x, because x is to the 1 power. So it takes a little bit of algebraic work here, but when we do the multiplication by 1 over x, we get this expression. Then we just use the fact that 1 over x is going to 0 and 2 over x is going to 0. We can see that the denominator is settling to 1 as x gets larger and larger, and we can see that the numerator is taking off in a positive way. So the denominator is settling to a constant value, while the numerator gets larger and larger in a positive way. And so what we say in that case is that the limit is equal to infinity. What about x going to negative infinity? Again, we look at the degree of the denominator. We've got x to the 1 power. So we divide by x to the 1 power. Or another way of saying that is we multiply top and bottom by 1 over x. And again, we do the algebraic manipulation. And as x gets very negative, again, 1 over x is going to 0. And the denominator, the denominator is settling to positive 1. But now the numerator is taking off not in a positive way, but in a negative way. And so we say that the limit is equal to negative infinity. Now, as I said, there are other strategies for a situation like this. One is to do long division. I could just take x plus 1 and divide that into the numerator, 2x squared plus 6x minus 2. And then 6 over x plus 1, that's going to 0, right? Because that's bottom heavy. 6 over x plus 1. That'll be going to 0. So the function will look more and more like 2x plus 4. And so if you anything you remember about slant asymptotes will help you in this case, but you'll get the same result. We're going to talk more about limits at infinity in part 3, and I look forward to seeing you then.